Hi everybody, I'm Mr. Burke, and thank you for tuning in to another episode of Beakers and Beards. Today we're going to be doing some basement science experiments as we explore the density of water. Now thinking back to last class, how did we define density? That's right, density is mass per unit volume. And remember, we can measure mass with grams or kilograms and volume in milliliters or liters. So we can think of density as how much stuff we'd be able to fit into a container. Now in this case, we're looking at the density of water. So how much water can we fit in this container? Now remember when we first started talking about water, one of the cool properties we discussed is that water has this magical property with density, where the density of water is equal to 1 gram per milliliter. And that's really important for what we're going to be doing today. And I'll show you why. One thing we know about water is that it's very easy to manipulate the density. So for example, if I have a container with water inside, as represented by these blue molecules here, how might I be able to change the density of this water? Well, one thing I could do would be to apply a change in temperature. In this case, we're going to heat up the water. Now, what do you think would happen to the density of the water inside that container if I heat it up? If you said the density would become less dense, you're absolutely right. When we heat water molecules, they tend to move around a lot more rapidly than they do with stationary water molecules or room temperature water molecules. Now, this increase in rapid movement also increases the volume because the water molecules become further apart. Now, if we remember our formula for density is mass over volume. So if I increase the volume, what happens to this overall number? That's right, the overall number becomes smaller. Think of it this way. If I had 1 gram in 1 milliliter, I would have a density of 1. But if I had 1 gram in 2 milliliters, I would have a density of 1/2. Or 1 over 2. So by increasing the volume, we're actually decreasing the density. The same thing works the opposite way. If I were to cool the temperature down by adding some ice cubes to the bottom of our water, the molecules would slow down. They wouldn't move as fast as they do when we heat it up. Their movements would be very, very small, and they'd tend to want to group closer together. This would make the volume of chilled water more dense because we're decreasing the volume because the molecules aren't moving as fast as they were before. If we look back to our equation here and we decrease the volume and go from 1 milliliter to 0.5 milliliters, then our density becomes 2. But what happens if we don't want to change the temperature of the water? If we just want to have standard room temperature water, how can we manipulate the density? Well, one way to do so would be by dissolving something into our water. So if we think back to this drawing here of our water molecules inside our container, we can see that these blue spheres are just kind of sitting there. There's plenty of space for them to move around, and they have a fixed mass because we know the density of water is 1 gram per milliliter. However, if we start dissolving some salt particles into the water, what do you think happens to the overall nature of our beaker? If you said that the mass would increase, you're absolutely right. By dissolving these salt particles, which are sodium and chloride, we're actually increasing the overall mass that we see within our container. And remember back from our equation, density is mass over volume. So if we're leaving volume alone, but we're increasing our mass, what do you think happens? That's right, our density becomes greater. So if our mass went from 1 gram per milliliter to 2 grams per milliliter, we would increase our density to 2. Now, a really cool way to be able to visualize this is what we're going to do in our experiment today. we're actually going to be stacking different densities of water on top of one another. You can do this, like I said, with some simple household items. So let's set the experiment up. So in order to conduct our home experiment, we're going to need a few household items. 5 drinking glasses or clear plastic cups, something to pour our water out of, a 1 teaspoon measuring spoon, some food coloring, salt, and water. Now first, let's talk a little bit about safety today. Nothing we're doing is overall toxic. However, you don't want to be drinking any of the solutions that we're making today. They're not going to leave a very good taste in your mouth, and they might dye your teeth some funky colors. Also, if you have any, it'd be a really good idea to wear some plastic gloves. The food coloring can stain your hands, so make sure you're protecting them at all times. Also, make sure you're wearing some clothes that you don't mind getting tie-dyed, just in case you spill some dye on yourself. So first things first, we're going to start by lining up our 5 different drinking glasses. And remember, wear your rubber gloves if you have them. This will save your hands from getting tie-dyed. Next, we're going to use our measuring cup to measure out 400 milliliters of our water. Then we're going to add the water to our cup. And then we're going to repeat the process for all 5 cups. Next, we're going to add varying amounts of salt to each one of our glasses. In the first glass, we're not going to add any salt. The second glass, we'll add 1 teaspoon, 2 teaspoons, 3 teaspoons, and 4 teaspoons. We'll give it a little mix and let the salt fully dissolve within the water. 1 teaspoon, 2 teaspoons, 3 teaspoons, and finally 4 teaspoons. Give those a quick stir each and help the salt dissolve. Your water is going to look more cloudy the further we go along the line here because there's more salt in there. That's absolutely fine. Don't worry about that. Just give it a good vigorous stir and all of your salt should eventually dissolve. If you need to wait a few minutes, that's absolutely okay. Now that our salt's all dissolved, we're going to add a couple drops of food coloring into each of our glasses. The first glass we'll leave clear. The second glass we'll make yellow. The third glass we'll make red. The fourth we'll make green. And the fifth we'll make blue. Give your colors a second to dissipate throughout the water, and if you need to give them a quick stir, that's okay too. Now for the last part of our equipment, and to start the experiment, we're going to need a clear plastic straw. And what we're going to do here is, because these liquids all have a different density, we should be able to stack them inside the straw in a color gradient, starting with clear and going all the way to blue. Let's see if we can do it. And there you have it. Blue, green, red, orange, and clear, all stacked because of the density properties of water. And that's it for our basement science experiment. Thank you so much for joining me this week. And remember, you can always do these experiments at home, but please make sure you ask your parent or guardian's permission before you go get the food coloring. I'm Mr. Burke, and thanks for tuning in to Beakers and Beards.